Hello everyone, this is Mike. Today we will start to understand the Saga pattern. So let's see today's agenda. First, we start with the transaction. What is the transaction and what's the problem we are facing in microservice architecture? And we will start with some solutions that will help to achieve the distributed transaction atomicity. So there we have two solutions, the 2PC and Saga pattern. So let's start. So before going further, let's understand what we are going what is this series. So in this series we will start with design patterns. So there we have there are multiple patterns like database service pattern, API gateway pattern, and much more. This is just a prototype, and we are going to understand all of the patterns which are using in microservices. So as a first part, what is transaction? So transaction is something that's related to the database, and a transaction should be atomic. So it should be atomic, consistent, isolated, and durable. In short, we are calling this ACID. Every transaction should be a acid, or we can say yeah. So each transaction should have a property of ACID transaction. So let's discuss the atomic. The atomic transaction is something that each statement in a transaction that should be treated as a single unit. It shouldn't be the case the some properties committed and some not. Let's suppose we have a table where we have a table having few fields, name, ID, and date of birth. So that should not be the case. There one data should committed and other is going to failed. The second is consistency. Consistency is something that ensure the integrity of the table. Like if database defines some integrity, like the age should not be less than 18, or data or the salary should not be less than 25k. So that consistency should be maintained in a transaction. And the isolation is something that make that 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 keeps the multiple users separation, like whenever two or more user working on same database, so each transaction should be treated as a separate. And there is durable is something that if data is if transaction is completed, then if transaction is completed, it doesn't mean if transaction is ensure the changes to your data made by successfully executed transaction will be saved even if the event of system failure. So these are four transactions type that should be obey the database. And there is a problem in multi microservices architecture where we have a multiple microservices. So in a single database we can ensure the ACID property, as database already obeyed the ACID transactions. But in case we have multiple databases or multiple microservices, then it's hard to ensure each database should obey the transaction that span multiple microservices. So for that problem, we are to resolve that problem, we come up with the some patterns like Saga pattern or 2PC pattern. So we are going to understand some scenarios, like we have a e-commerce system where we have multiple microservices. So in this scenario we can have order service, we can have payment service, we can have stock service or delivery service. Each service will do their work. Order service is responsible for getting the order from the user and process it for the further. So after getting the order, the payment service will come up the next and ensure the payment ensure the payment should uh, should be made very smoothly. So for that, there are two service. If let's suppose a scenario, if payment goes fail, then the order should not be accepted. So this is the case where multiple services will come and will will treat it as a single transaction. So for that, we are going to start with an example. Okay, so this is the use case we have. So we have we are going to take the example of e-commerce application where we have multiple microservices, or the order service, payment service, stock or delivery service. Order service get the order from the consumer, payment service get the order and get the payment and mark the transaction as successful or a failure. And after getting the payment, the stock service will update the stocks and delivery service will deliver the product at the consumer address. So in a scenario, the yeah so there is a scenario, the user comes to our website and place an order service get the order, update the stocks, make the payments and deliver the product. If any one of them is failed, then other microservice need to revert the transaction. So suppose a scenario, if payment goes fail and order service receive an order, and this service should need to be reverted their transaction if order is accepted. So in this case, there are some pattern which are going to communicate with multiple microservice and make that transaction which span multiple databases should be treated as a ACID. So first we have a 2pc commit. 2pc commit is two-phase commit. So before making a transaction, the coordinator service or the main service will ask to other nodes that are involved in a transaction if they are ready for commit or not. So coordinator service will send an acknowledgement message, send a request to ask are they ready for the commit or not. If both services say yes, and the services which say yes, then these services acquire the logged on their databases. So in that part of time, in that mean of time, no transaction will happen on that table. So once both services revert the acknowledgement with yes, then coordinator service will ask them to commit the transaction. If both service successfully commit the transaction, then they can release the logs which was acquired previously at the prepare stage. If any of the service not able to update the database or failed, then then the service will return with the other status, failure status. Then coordinator service will ask to both services to revert their transaction. So in this way, two-phase commit is helpful to achieve the ACID property in in distributed environments. So there are some advantage or disadvantage of this service, this pattern. The advantage of 2PC is we can achieve the distributed transaction, but there is a some disadvantage, like in 2PC commit we have to block all of the database and make the locks on the database, so it consumes some time. And in meantime of the prepare phase and the commit phase, there is some time, so that time basically increase the latency, which cause an performance issue. And there are some databases that is not able to perform the 2PC, like NoSQL database are not supported for 2PC. So there are few advantage. To overcome this problem, we have another pattern also, which is called Saga pattern. So Saga pattern is kind of sequence of local transaction that are in coordinated in a distributed manner to ensure the data consistency across the multiple microservices. So why the Saga pattern? So the solution is simple. Reason is very simple, because Saga pattern obey the ACID properties and maintain the data integrity across the multiple services. So let's understand what are the types of Saga pattern first. So there are two types of Saga pattern, first in choreography and orchestrator. We will talk first the orchestrator. So orchestrator Saga pattern is basically a central control service, we can say. There is a one central controller which can be a service. So in this case we have order service as a orchestrator. The client request for an order, and that request landed to the order service, and order service will responsible for making the payments, stocks and delivery to communicate with these three services. Once getting the order from the clients, it will pass the data to the payment service to complete the payment, and for the stock service to update the latest stocks after detecting the user stocks, and the delivery service. So there is a one single service that is going to communicate with other microservices. So this is called Saga pattern, Saga orchestrator based Saga pattern. Okay. And there are some advantage and disadvantage too. The advantages are like good for a complex workflow. If multiple service comes up in this type of pattern, in this type of transaction, if let's suppose the transaction span with 7 microservices, then we can add multiple services, and that services will communicate with the order services. There is a one single service the that maintain the orchestration in a single service. No need to worry about the other services, like how can they maintain these things. So this is the first thing. And all of the tracks, all of the instances, all of the process can be handled by the single service, and there is there no there and there is no we can say cyclic dependency, as there is a single service is going to orchestrate the other services. So order service is totally responsible for that, and this is the single disadvantage of having a single central point. So this could be a single this will be a single point of failure. If order service goes down, then the whole system will goes down too. So, and there is one more disadvantage, which is latency increment. If single service doing all of the stuffs, in that case the 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 latency of this service will increase, so performance goes down in this scenario. There is one more type of pattern, Saga based pattern, which is choreography. In choreography, what will happen, there is a order service. The consumer going to place the order, and order service receive the event from order created event. Once it receive the event from this event, then it will process with the payment service. What payment service will do, payment service will emit the will consume the event and will process for the payment and emit the event on the build order event, and the stock service will receive that event from build order event, and it will update the stock and just send their status on the other event. In this way, all whole services will communicate each other by using the events. So there is no coupling and there is no central point of coordinator. Each service will produce the event and consume the event. Based on event, they all service working is seamlessly. So this is a decentralized way to achieve the pattern achieve the saga pattern. And there is some advantage and disadvantage too, like this is good for a simple workflow where where the number of services are less, so it's easy to maintainable, and there is no coupling as all services are independent. They just keep reading the data from the event and writing back data to the event. And service can be a more resilient uh, if some framework can be added in these services, like circuit breaker or bulkhead patterns. And there is few disadvantage. If any service goes down and unable to perform their operation, it's hard to get where its goes failed. So it's harder to debug and maintain the application, and maintainability cost will increase in this case, and there may be chances of cycling dependency, and integration testing is very difficult there, as if there one more service going to added there, then one more event need to be created and the whole communication will reflected there. So we have to careful when adding new services there. So this this is the flow of choreography. So there are a few things that we need to keep in mind while implementing the saga pattern. So there could be a case if one service goes down. Let's suppose client receive an order, uh, client send an order, and that order landed on the order service, and this service is going to communicate with other services, okay, payment, stock and delivery. And somehow stock service goes failed, and it will revert the response with the failure. Then this is the responsibility of order service, which reads the status of stock service and trigger more events, and send the request to the payment service to revert the transaction. So there can be two scenarios. Either order service will go to revert the transaction or will retry the transaction. So if stock service goes failed, the order service will ask the stock service to retry to update the stocks. So stock service will retry to update the stocks. If it goes successful, then order service will go ahead and ask to delivery service to deliver the order. Otherwise, it will say backward it will go to the backward. It say if stock is goes to failed, then we are going to revert the whole transaction. So it's called the payment service. Payment service will revert the payment and send back the status to the order service, and order service will revert the status and acknowledge to the user. In same way, the orchestration is also work. If any of the service goes failed, it will trigger an event to any topic, and that topic will be consumed by the other service, and that service going to revert the transaction. And at the end of this, the order service event will get an event of failure, and that event is listened by the user. So this is the flow in both services, in both patterns. So now we can discuss the both patterns, 2PC and Saga pattern. The consistency model in 2PC is very strong. Reason being, the reason being of having a strong consistency in 2PC, the 2PC log the entire microservices that comes under a single transaction. So in this way, it will log the all the services and update the records and just release the logs. So this becomes a strong consistency there. And in Saga, this is a eventual consistency. The reason being, one service get the request and it will update their status and called for another other service to update their status. So this is the case where consistency should be eventual in Saga pattern. Consistency can be eventual there, and performance is slow in 2PC due to blocking nature. It will block all the database, and this is the main drawback there. And Saga is literally little bit faster, as the parallel execution can be there. Scalability, 2PC is limited to scalable, as logs are the main priority there, and Saga can be scalable highly. Cause if there is no locking system, all service works. And failure handling, yeah. So in Saga, we can handle the failures we by using other frameworks like circuit breaker and other things. So this can be happen. And in complexity, 2PC is simple to understand and implement the 2PC pattern in the microservices. And in Saga, this is quite complex to implement the Saga pattern and requires carefully designed. The reason being, having a compensating transaction. The compensating transaction is something that undo the effect of the transaction. So there, if this service is going to ask to revert the transaction, that means we are going to compensate the transaction there. So this is the whole idea of having a Saga pattern. If you guys have any questions, just write in the comment section. Thank you.